All right, so over the last couple of decades, something really big happened in the world of data. A quiet revolution, you could say. And what's interesting is, it wasn't about fixing something that was broken. Nope. It was all driven by a single, massive new problem. Today, we're going to dive deep into that shift, the rise of what we call big data, and the not only SQL movement that it kicked off.
I mean, think about it. For decades, relational databases were king. They were the gold standard, right? Super structured, incredibly reliable, and powerful. They literally built the digital world we all live in. So that leads to a really important question. If the system was working so darn well, why on earth did we suddenly need to go and invent something completely new?
Well, the answer is, it wasn't about fixing a flaw in the old system at all. It was about facing a totally new kind of problem. A problem of just sheer scale, incredible speed, and mind-bending complexity. And it was all born from the data explosion that came with the modern internet.
And that problem, you guessed it, has a name: big data. Now let's be clear, this isn't just about having more data. We're talking about an absolute flood, a deluge of information pouring in from social networks, from all our web apps, from huge transactional systems. And it was this flood that basically pushed traditional databases right to their breaking point.
You know, the challenge of big data really boils down to three things. People call them the 3 Vs. First up is volume, and the scale here is just staggering. To give you an idea, get this. Way back in 2013, Facebook was already adding 350 million new images every single day. Insane, right? Next up, velocity. This data isn't just sitting there, it's streaming in at these unbelievable, relentless speeds. And finally, variety. Yeah, forget your neat and tidy rows and columns. We're talking about the messy, unstructured chaos of the real world. Images, server logs, social media posts, you name it.
So what do you do when you're faced with a problem like that? Well, engineers didn't just throw out decades of database wisdom. That would have been crazy. Instead, they expanded the toolbox. And that's a really key point. This wasn't a revolution to replace SQL. It was a necessary evolution, a way to handle these wild new data challenges.
Actually, the name NoSQL itself can be a little misleading. A much better way to think about it is no relational. The whole point wasn't to get rid of the SQL language itself. That's still super powerful. No, the idea was to explore data models that weren't locked into that rigid, table-based structure of a relational database.
And this whole movement was really born out of pure necessity. It all started in the early 2000s with the Web 2.0 boom. Suddenly, there was this fire hose of user-generated data. By the mid-2000s, the big tech giants like Google and Amazon were scrambling. Nothing on the market could handle their scale, so they had to build their own custom systems. And then, by the late 2000s, the ideas from those internal projects started to leak out and spark this incredible open-source movement, which ended up giving these powerful new tools to everybody.
Okay, so this led to a whole new toolbox of databases. And remember, NoSQL isn't just one single thing. It's more like a family of different types of databases, and each one is purpose-built for a very specific kind of job.
So let's break down the 4 main types, or flavors. First, you have key value stores. These are the simplest and fastest. Just think of a giant, super fast dictionary, perfect for things like caching or managing user sessions. Then there are document databases. These are awesome because they store flexible documents, like JSON. Great for content management or mobile apps, where every user profile might look a little different. Third, we have column family stores. These things are absolute workhorses, built to handle enormous amounts of data, especially when you're writing data all the time. And last but not least, graph databases. These are all about the connections between data. They're the magic behind social networks and recommendation engines.
Okay, to really wrap our heads around how different this new way of thinking is, let's zoom in on one of the most influential types, the column family store. This is the model that really came out of those tech giants like Google and became a cornerstone of the whole movement.
The difference here is absolutely fundamental. On the left, you've got the classic relational model. Think of a perfectly neat, orderly spreadsheet. Every single row has to conform to the same set of columns, no exceptions. But on the right, you have the column family model. The best way to picture this is like a file folder for each user. Each folder gets a unique ID, but inside, you can stick whatever documents you want. It is complete flexibility built right in.
Now, this model has its own lingo, but it's pretty straightforward. The key space? That's just a container for everything, kind of like a database schema. The row key is the unique ID for each row, just like a primary key. Simple enough. But here's where the magic happens: column families. This lets you group related columns together. So you could have one family for all of a user's profile info and a completely different one for all their recent activity. It's this clever grouping that lets these databases scale and perform so incredibly well.
All right, so we've got these cool new ways to store massive amounts of flexible data. Great. But that leads to the next big question. How in the world do you actually process it all? How do you run a query without it taking, forever? The answer was a really elegant processing model called mapreduce, designed from the ground up for these huge distributed systems.
It's a beautiful, simple two-step process. First comes the map step. This is where the system takes a massive task and it breaks it down into thousands of tiny, manageable jobs. Then it sends those little jobs out to hundreds or even thousands of computers to work on at the same time. Then comes the reduce step. The system just collects all the answers from all those little jobs and combines or reduces them into a single final result. It's the ultimate divide and conquer strategy for big data.
So, you see, these big innovations, these new types of databases, and these new ways of processing data, they didn't just exist on their own. They all started to come together to form this powerful, complete ecosystem for taming big data. And probably the most famous example of this is the Hadoop ecosystem. It's easiest to think about it in layers. At the very bottom, you have the Hadoop Distributed File System, or HDFS. That's the foundation, a special file system that can store gigantic files across a whole cluster of machines. Then, sitting on top of that storage layer, you run a database like hbase, which is that open-source column family store we talked about. And finally, to actually analyze all that data, you use a high-level language like Pig, which makes it way easier to write those big MapReduce jobs. So at the end of the day, it was never really about SQL versus NoSQL. That's the wrong way to look at it. Relational databases are still absolutely crucial for tons and tons of applications. The real takeaway here is that modern data problems just require a bigger, more versatile toolbox. It's all about looking at your data, understanding its shape and its challenges, and then picking the right tool for that specific job. Hey, if this helped you get a better handle on that modern data toolbox, do me a favor and hit that like button, and be sure to subscribe for more explainers just like this one. And I'm really curious, let us know down in the comments what's the biggest or most interesting data challenge that you're working on right now. Thanks so much for watching.